So today's video is about exponential transformations. This is our second try at this video because the first time the 11-minute video was only 2 seconds. So let's hope this one works. So today we're doing exponential transformations and you're going to need your calculator because we are going to use the table function in your calculator. So if you notice though, I've already graphed the parent function on every single graph on today's notes. So all I did to do that was I turned my calculator on, I went to table, right here, table, and I cleared everything out that was there. I did 2 caret key X, pressed enter, made sure my 0 was my start, and then just found some nice points. So 1, 2, 4, those are nice. And then I went the other direction. I was like, okay, I can graph a half. If I go up again, a quarter, probably not going to graph that one, but I could. Anything else is too small. And if I go the other way, 3/8, I can still graph, but 4/16 is too big. So that's just where these numbers came from on this table that I then graphed for you as the parent function, as the black line. So another thing to notice that we talked about on Friday is this +0 at the end here. So for letter B, it's 2 to the x plus 3. So this +3 right here is going to be our asymptote. So when we start graphing, that's going to be the first thing I need to put on my graph, and then I can start plotting points. So now that I have the asymptote on the graph, I'm going to go back to my calculator, go to table, and I need 2 caret key X. And so 2 to the X, it's highlighting up top still. So you're going to need to press to the right until your little box that's blinking is big again. Then you can put a +3 at the end. So enter. My start's at -1, just make sure it's 0. We always like 0 to be in the middle if we can. And keep pressing enter until it shows up. So I have 4, 5, and 7. Those are good points. And I have, let's see if I go up, -1 is 7/2. But remember, if you highlight it, you can then use your double arrow key down here, and it makes it into a decimal for you. So for this, we are going to use XY. Put 0 in the middle. So 0 is 4. 1 is 5. 2 is 7. Then I'm going to go the other way because I always need points on both sides. So if you think of a number line, you have 0 in the middle, you want a couple points to the right and a couple to the left. So -1 is to the left of 0. So we already said that 7/2 is 3.5. So -1 is 3.5. If I go up, -2 is 13/4. I have no idea what 13/4 is, but my calculator will do it for me. So it's 3.25. So this is the table we are going to end up graphing. So check to make sure that your calculator matches my table. Okay, so next I'm going to actually plot these points. So I'm just going to start on 2. I'm going to start at the bottom of the table. 2 is 7. 1 is 5. 0 is 4. -1 is 3.5. And -2 is 3.25. So it's basically almost on the line. Then you connect these. And they are the same shape. The only difference was I started off with this black graph and now I'm up here with the green graph. So it's been shifted upwards. I took everything and just moved it up 3 flights, basically. So I added to the end. That's going to be a vertical. And whenever you're moving up, down, left, or right, it's called a shift. You're shifting the graph. So a vertical shift up blank units. So in this case, it was a vertical shift up 3 units. Okay, let's go to the next one. So again, I'm going to go table. It's 2x plus 3 in here, but I need minus 5. So I'm just going to arrow over until I get to my plus sign. I'm going to make the plus a minus and the 3 a 5. And now it looks exactly like what I need. Enter. Start on 0 again. Okay. So let's try putting 0 in the middle. So 0 is at negative 4. 1 is at negative 3. 2 is at negative 1. Oh, I can graph that. 3 is at 3. And 4 is at 11, but that's off my graph. Oh. Okay, let's go the other way. Let's see if we can find spots on the other side of 0. 0, so negative 1 is negative 4.5. Negative 2, let's see, is 4.75. It's negative 4.75. And if I keep going, I just keep arrowing up, negative 4.999. I'm getting really close to negative 4.9999 is really close to negative 5, and that's your asymptote. So you can always keep arrowing up if you're not sure what your asymptote is. So my asymptote is at negative 5. So draw your dashed line and go ahead and plot these points. Okay, so 3 is at 3. 2 is at negative 1. 1 is at negative 3. 0 is at negative 4. Negative 1 is negative 4.5. And then negative 2 is negative 4.75, which is almost on the 5. So if I connect these, should be the same shape as my parent graph. But the only thing we did now was I took it and I shifted everything down 5. So when I subtracted, it's a vertical shift down blank units. Vertical shift down however many units. So this one would be a vertical shift down 5 units. Okay, let's go to the next one. Okay, so the next one, again, I have given you the parent function. So now I'm going to type this into the calculator. So let's go ahead and go to our table, delete what's in there, 2 caret key, and now it's an x plus 3. So make sure the plus 3 is up top in your exponent, just like the original equation. Enter. Oh, look, I'm on negative 26 as my start. So go ahead and change that to 0. Enter, 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 enter. Okay, so this is the graph, this is the table, you should have. So 0 is 8, 1 is 16, and 2 is 32. So the only thing from right here I can graph is the 8. If I keep arrowing down, these numbers are just going to keep getting bigger and bigger. So that's not going to work. So I know I need 0 is 8. Zero is 8. So I'm going to write that down. 0 is 8. Negative 1 is 4. I'm just going to go up and keep writing the numbers going up because those look like viable options. Negative 3 is 1. And negative 4 is a half. I'm not actually going to graph a half though. So these are the 4 points I'm using. So to figure it out, you're just going up and down and figuring out nice points. So go ahead and, oh, I have a question. What's your asymptote for this problem? Okay, so your asymptote for all of these, there is no number at the end. So both of these is an asymptote of 0, which I already have graphed from the parent function. So I'm not going to worry about that. Let's just graph these points. So 0 is 8, -1 is 4, -2 is 2, and -3 is 1. So your graph should look like that. So for this one, I didn't move it up and down because the asymptote stayed the same. For this one, though, I'm looking from this black function to my green function, and I took each point and shifted it left. I shifted it left 1, 2, 3 spots. So for this, if it's added, and we're talking about in the exponent now, with the x, if it's added, it's a horizontal shift, and we went from black to green, which is to the left. Left blank units. Okay, go ahead and see if you can make the table for 2 to the x minus 5. And then once you have your table, check your table with mine, so unpause the video. And when your table's correct, then go ahead and graph the function as well. Okay, so your table should look like mine. So when I was in my table, 2 to the x minus 5, if I start at 0, I have these fractions. If I go up, they're not helpful, right? 1 over 256, like what the heck is that? So let me arrow the other way. And I'm just arrowing down until this right column, I get something nice. So right here, 4.5, I can do that. 5, 1, 6, 2, 7, 4, and 8, 8. All of those are nice points. So if you have the same table as I do, go ahead and graph these points. Okay, so your graph should look like my green one. And again, we're comparing it to the parent function. So for this one, I took my point and I went to the right now. So when you're subtracted, it's going to be a horizontal shift right blank units. So it's opposite of what you think. So if you want to put a little note at the top, it's opposite of what you think. A +3 really means, when you think +3, I think to the right 3 because it's a positive, but it's really to the left. When it says -5, I think left, but -5 really means you're going to the right. And you will get a cheat sheet on this tomorrow, so you can kind of see where everything is coming from and why it does that. Okay, go ahead and watch video number 2 for the back of the note.